Let's look at this first one. It says h is a polynomial function. Let h prime, its derivative, be defined as this. So it's given us h prime. How many points does the graph of h have? A relative maximum. Remember, relative is the same as local. And we're given h prime. So we're given the derivative. We're not given h. So I'm going to make an x-axis for a sine line graph for h prime. Okay, so I want to know pretty much where h prime is above the x-axis or below the x-axis. Because if I know where h prime is above the x-axis or below the x-axis, then I know where h prime is positive or negative, right? But I don't have a y-axis because that's just going to muddy the waters. Let's just put in our x-intercepts. You guys know what the x-intercepts are for this guy?
0, 2, and 1.
0, 2, and 1. So I'll put 0 right here, 1 and 2. Okay, you guys good with that? Correct scaling doesn't really matter. This is just to help our visually learning brains. Okay, so the question is, are we above or below the x-axis here? Are we above or below the x-axis here? Are we above or below the x-axis here? And are we above or below the x-axis right here? Now, if you guys know, there's 4 intervals. If you guys know how to curve sketch, that really helps. I'm going to curve sketch. Instead of curve sketching, you could test points. You can test numbers. Like you can plug in -1. You can plug in -1/2. I'm sorry, that's not negative. Stupid. +1/2. You can plug in 3/2, and you can plug in 3. You can plug these numbers in and see if you get a positive or negative, or you can curve sketch. Okay. Now, personally, I think that curve sketching would be much faster right here. So that's what I'm going to do. So it's really helpful to remember the, the LC up here. So is your LC positive or negative? That's leading coefficient. And what is your deg? Your degree. Are you even or are you odd? Okay, I know I have this on the board right here, but even would go up for a positive LC, and it would go down for a negative. Odd would go down, up, and even would go up, down. That's where the end behavior is. You don't know what end behavior is? Search it up. Put my name on it. You'll find a cool video for it. So I'm thinking about this x-axis where I have 0, 1, and 2. I know that 0 has a multiplicity of 2. Now, multiplicity is another concept. So I talked about end behavior right here. I don't care. And the other one is multiplicity. Multiplicity tells you whether the line that you're sketching goes through the x-axis or bounces off the x-axis. If the curve bounces off the x-axis, that means it stays on the same side of the x-axis and doesn't change sides. And so, check this out. If I were to multiply this out, the leading coefficient would be positive. And I know that because x is the first term here, x is the first term here, and x is the first term here. We would have a positive leading coefficient. So we have one of these scenarios happening. Now, is my degree going to be even or odd? It's going to be even. That's because this is an x squared. When I finish this 2 right here, this power of 2, this will also be an x squared. And then if I finish this power of 2, this will also be an x squared. So it'll be x squared times x squared times x squared. So the degree would actually be 6. Okay, so we have a degree of 6. This is our scenario. We have an end behavior that's up. So I'm going to put my corners up here to remind me. And I'm going to go down to my first x-intercept. And I know we're going to bounce because the multiplicity is 2. Because there's 2 x factors that give you a 0. And then I'm going to go up and I'm going to come back down to this x-intercept. Am I going to bounce or go through the 1? Well, 1 comes from 2 x minus 1s. Therefore, we're going to bounce off the 1. So I bounce off of that. And then I'm going to go up and come back down to the 2, to x equals 2. That one has a multiplicity that is also even because of this 2 right here. So we're going to bounce off of that one and then go up. No, this one never goes negative. So you know what that means? All of these are positive. That means if I were to look at h, which we don't know, h would look something like this. It just keeps, well, maybe not vertical like that, but it like levels out and gets a slope of 0. Those are your x-intercepts, and then would just keep increasing. So that means this h is just continuing to increase. We're not going to have a relative maximum anywhere, because in order to have a relative maximum, we have to be increasing, then decreasing to have a relative maximum. So that means we have to have a positive slope, then a negative slope. We don't have positive, negative anywhere here, so you're going to say none. Or how many points? Yeah, there's none. 0. Okay, so I want to point that out. Thanks, Josh. If you were actually testing the points because they're all getting squared, it would be positive. Good job, Josh. Way to let me explain. You just let me go. You're like, Mr. Pitt, he really wants to curve sketch, so I'm gonna let him curve sketch.
Let him have his fun. Yeah, let you have your moment.
Yeah, so I guess you guys have to choose, right? Which tool is gonna give you the answer the fastest? All right.